Hi friends, very good evening and thank you for joining in. Could you please confirm on the chat window if you're able to see my screen and hear my voice clearly so that we can get started with the actual discussion itself. Okay, I'll just wait for your confirmation on the chat window. Okay, cool. Very good, very good, very good. Okay, so everything looks to be going good. Okay, I can also see myself. I can also see my screen and hear my voice on my own computer. So I'll take your questions on the chat window. Okay, good, good, good. Hey Kashif, yeah, thanks for taking the time to share your journey yesterday. Thank you very much. Thank you for joining today's session also. Cool. So Derek says, hey, if I start the course next week, so let's say it's middle of June, will I be able to go through by September if I put 3 hours per day? Again, Derek, that depends a lot on what you already know and what concepts you're already comfortable with. Again, if you're beginning everything from scratch, if you're putting in like 10 to 15 hours a week, assuming that you're an average student, you'll take about 6 months to complete it. So unless you're very comfortable with programming and you know some of the concepts, trying to finish everything in 3 months is very ambitious. While we have had students who have done that, they have put in significantly more than 3 hours per day. We've had students who finished everything in 3-4 months, but that's not the norm. We don't want to even quote that publicly because more realistically, you'll take about 6 to 8 months to complete. Cool. Cool. So some of you who are our course enrolled students are asking that you've not completed whole of everything. Ajinkya says, very interesting name. Ajinkya says, I've just finished module 1 till SQL queries. Can I watch this video? Ajinkya, it might be a little hard for you because these questions typically are not just coding related. These questions go into the details of data science, machine learning, and deep learning. If you know some of these concepts, certainly you can attend this interview and make the most out of it. But don't worry, in case you have not learned these concepts yet, this will be available on YouTube itself for non-course participants. As far as course participants itself is concerned, we'll add it back to the course videos as live sessions. You can watch it whenever you reach that point. Okay. So Prithvi is saying, do you have any plan to start the PG online course? So Prithvi, we are in discussions with University of Hyderabad to start the next batch for PG diploma. Again, till the time we get an official confirmation with all the details, we will not be able to confirm the exact dates. But if everything goes through, we will have the second batch for the diploma in collaboration with University of Hyderabad in the second half of this year. Surya says that he's facing a little hiccups with the clustering assignments. That's okay, Surya. Again, by the time you come to clustering, you already went through a good chunk of assignments and course concepts. That's why we try to make them slightly harder because we want to prepare you for all sorts of interviews and for all sorts of real world challenges. So in case you're finding it too hard, even after attempting it and trying it out using online resources, always reach out to us in the classroom. Our mentors will help you. They'll give you hints. They'll give you direction. They'll give you more pointers through which you can solve it better, right? So if you're stuck for too long, let's assume you're stuck for a couple of days, you're not able to make progress, shoot an email or send a message in the classroom and our team will help you. Cool. Okay, this is again, I'll take a couple of questions. Let everybody join in. We'll start the session itself at 7:02. I'll take one more question probably. Okay, so this is a question from Saptak. So Saptak says, how to shift from a data engineering role to a machine learning role. Again, Saptak, the good thing here is as a data engineer, you already work with data pipelines, you know data pre-processing, data cleaning, SQL, and things like that. So you already know some of the engineering aspects of data science and machine learning. What you need to build now is, of course, you also know a lot of programmatic details. So what you need to know now is the mathematical the applied and the foundational knowledge. For example, you need to pick up statistics, you need to understand machine learning algorithms, deep learning algorithms, and apply them to real world problems. So that way you can easily build on top of your data engineering skills and transition to careers in data science and machine learning, even deep learning. Okay. So with that, let's get started. Again, folks, I promise you that I will surely spend some time on the chat window at the end of this session. I'll try to spend about half an hour answering all of your questions. So let's get started. Since it's already 7:02, let's get started with today's discussion. It's going to be fun. I was looking forward for this session. So today's session is called the scenario-based interview questions across data science, machine learning, and deep learning. So I'll explain you what are scenario-based questions and why they're important, and let's get into the details of it. Again, we will try and showcase multiple problems. I think I have 6 or 7 problems, because typically we have been only able to solve 5 to 6 problems in these live sessions, because we also want to have some time left at the end for general Q&A. So we will tag these questions as easy, medium, or hard, just to make sure you understand where they stand. Typically, hard questions you will encounter in product-based companies. Medium, you'll typically encounter them in product-based startups, some of them even in large product-based companies. Easy and medium is what you'll encounter in services companies. Again, most of these questions are actually actual interview questions that our mentors, our advisors, our students have actually encountered. Some of them have been modified slightly. Okay. Again, in many of these scenario-based questions, you're given a real-world scenario or a real-world setup, and you're asked, what will you do here? So for many of these scenario-based questions, there is no one right answer. There are a lot of right paths. So given a scenario, you can take a different path. Someone else might take a different path. Oftentimes in these scenario-based questions, given a scenario, let's assume you answer something, there will be follow-up questions. So I will try and mimic this in this session. Again, this session is going to be fairly interactive. I strongly request all of you, I also recommend all of you to participate in the chat window. I will take the paths that you guys pull me in different directions. That's what makes these interactive sessions fun. Again, this is also going to be, some of the questions will be open-ended. So please feel free. I will give you counters in the sense that if you suggest a technique which may not work, I'll try to give you counter examples as quickly as I can, just like a regular interviewer would. The purpose of the scenario-based questions is to test your breadth of knowledge, depth of knowledge, and most importantly, your applicative knowledge. Whatever theory that you've learned, can you apply it to real-world scenarios? That is the whole objective. A lot of scenario-based questions are also asked based on the projects that a team currently is working on. A lot of scenario-based questions that I've seen, even as an interviewer that I've asked, are questions that are related to projects that I'm currently working on. Or it could be the team's projects, whichever team you're interviewing for, that team's projects, or it could be your projects that you've worked on. Right? So a lot of scenario-based questions also can come from this. Okay. Here, we will keep it slightly open-ended. We'll give you a flavor of all the questions. Again, please do not forget to participate via the chat window. Again, all the general questions you have, I promise you, we will have a Q&A at the end of this session. Right now, I will not be able to answer because we have a bunch of interesting discussion questions ahead of us. Right? So let's get to the first question. Okay, let me explain the question for you, just for the benefit of everyone. So the question is as follows. So you've built an automatic ticket assignment system. Imagine if you're working in an IT company or a BPO, any company, right? Suppose you have a machine learning model M, for which you're getting some tickets. It could be technical tickets, it could be some customer service tickets, any ticket that you're getting. You built this ticket assignment system to given any ticket, it will assign it to person 1, person 2, person 3, whatever it is, based on whoever is the best person who can answer a given query or a ticket most optimally. Most IT services companies have some form of ticketing system for their software. Now imagine you've built this system, all this is cool, your team probably worked on it, you also worked on the whole machine learning or the deep learning part of building this system. Now your vice president comes and says, hey, this is cool, this is very good, but what is the business impact of this whole model M over the earlier system, which was just a manual system? Now the question here, again, remember, a VP, like somebody who is a senior director or a vice president or a senior VP, will care about business impact of systems that you build. Now, Imagine you're the machine learning scientist or the data scientist who worked on this. How will you now answer this question to your vice president and say, hey, this is the business impact? How do you quantify the business impact? And I mean, this is a real world problem. This is a problem because at the end of the day, the senior management cares about business impact, not how fancy model you have, whether you've used a BERT model or a GPT model. Nobody cares. The senior management cares about business impact. Now, the question here is, how do you answer this question that a vice president is asking you? Again, this question is considered easy, not at all hard. This question is something that a lot of IT services companies could ask you, or even some product-based companies could ask you. Okay, so looking forward to hearing your thoughts in the chat window. Okay, I'm just looking for some thoughts. I'll write all the interesting thoughts here itself, right? Cool. So somebody is saying we want to provide resolution faster, right? So faster resolution. But how do you now? Okay, so let me just write it down, right? So let's keep the discussion open-ended. Whichever direction you guys take me in, I'll go into it. Okay. Faster response. Okay, interesting. Automation saves a lot of manpower. Okay, so saved manpower. Okay, saved manpower. Okay, I'm just writing everything here. Time saving, resolution time, response time. Okay, faster resolution, response time is part of this, right? So that's all there. Reduce the cost, saved manpower or cost, right? So interesting. Incident resolution costing, latency time would decrease. Again, all these are logical, right? These are commonsensical. Now your question that the VP asks is, I mean, he's not a dumb guy, right? He didn't become a vice president because he was dumb. He understands that these things must be happening. But how do you quantify and justify that? How do you show numbers to him? How do you quantify and say, hey, I'm very sure that we have faster resolution. How do you prove that? What sort of analysis or what sort of quantification will you do? And I mean, how do you say that this much manpower is saved or this much cost was saved? How do you go ahead and quantify that? Or customer satisfaction. Okay. That's an interesting point. These are all interesting stuff, but the most important thing here as a data scientist, because these things are commonsensical, right? Even somebody who doesn't know data science can say, hey, we are resolving it faster, we are saving cost, we are saving manpower, customer satisfaction is high. Okay, so let me just open a regular window and start writing your ideas here. Okay, less number of breach tickets, all of this. So somebody is saying that they will try hypothesis testing. Okay, others are saying, okay, a couple of you have said very interestingly that you'll do A/B testing, right? Now, can you elaborate on that, please? So first thing, so the metrics that you have said are perfectly all right. So how do you do the A/B testing here, or how do you do the hypothesis testing here? Can you elaborate, please? Please feel free to write your answers in detail so that I'll try and read them as much as possible. Okay, so this is the methods and what some of you have suggested here. Again, I'm just keeping all of you can see the chat window. So there are multiple metrics that you guys have suggested, which is turnaround time, right? So these are all metrics, sorry, turnaround time, right? And cost saving, right? Customer satisfaction. So all these, if you can measure them, great, but how do you measure them? Let's take one of them, right? So let's take one of them just for simplicity. Let's say you want to measure turnaround time. Okay, let's assume this is a metric that your business cares about. Of course, whatever method we come for turnaround time, let's just call it TAT, right? The same thing we can also the same methodology we can apply for cost saving, customer satisfaction, etc. as long as we can measure them. Okay, so let's assume we want to measure turnaround time and go back to our vice president and say, hey, the turnaround time increased or decreased. How do we do that? Again, I see some of you who are saying that the advantages of this. I completely understand that automating this will do all of that. But the question here is, you have to quantify the business impact. Please don't forget that. The generic answers any Tom, Dick or Harry can give. I'm looking for more quantified results. How do you quantify? How do you write a one-page report to your vice president and management saying, hey, this is the business impact of this? Okay, so some of you are going in the right direction. Okay. Again, some of you suggested A/B testing here. So let's go down that path, right? So let's go down that path. I'm just mind mapping here. Some of you are suggesting ANOVA. So in hypothesis testing, I think some of you are suggesting ANOVA. Okay. How many tickets were assigned manually and how many automatically in one day? Manoj, the problem in your, okay, so Manoj has one idea. Let me tell you a problem with that, right? So, okay, let me not write his name. So he's saying how many were resolved when, suppose you had a manual system and you had a model-based system, right? So he's saying of all the tickets that came, how many were resolved in one day using manual and using model-based system? Probably the whole SLA for this whole system is 24 hours, and hence both manually and model-based, everything got resolved in 24 hours. Then you don't have anything to show, right? Again, I'm trying to read as many comments as possible. Some of you went in an interesting direction. I think one of you suggested, or at least some of you suggested A/B testing. Now, how do we conduct A/B testing? How do we conduct A/B testing? How do we set up the whole A/B testing framework? Oh, some of you also suggested AAB testing, right? So that's also perfect. That's also a good idea. This is actually a stronger idea, obviously. Okay. So what some of you are suggesting with A/B testing or AAB testing is as follows. Okay, you're saying let's get all the tickets that we have. Let's assume this is the pool of all the tickets, right? A percentage of them. So let's assume I have A, B. This is actually a better test, to be honest with you, than simple A/B. So you can send some, let's say, some X% of traffic here, right? Again, some X% of traffic here, some B, or in other words, better still, so let me just pick some random numbers here. Let's assume the number of tickets is non-trivial. It's fairly large, let's say. So you can just leave some, okay, because you don't want to disrupt your current system. You can say, hey, 70% traffic, I'll put it here, 50% here, or 15% here, and some 15% here. And because the size of the number of tickets, let's assume you get 1,000 tickets now per day. Then you would get 150 tickets here, 700 tickets here, right? And another 150 tickets here. Let's assume A is all manual. Okay, let's assume these are all manual. Currently, what is existing, the status quo, let's assume, is a manual system. And this is a model-based system. Now, since there are 150 tickets here, 150 tickets here, makes a lot of sense. You can compare them apples to apples. There is no advantage of volume, because if you compare 70 and 30, you may have some volume advantages here. So 150, 150, fair enough. Okay, so this is good. This is like a neat setup. Now the question here is, okay, suppose, again, we discussed a while ago that we want to measure turnaround time. So let's assume for these 150 tickets, you have turnaround time. Okay, you have turnaround time. Let's call it manual, right, on the 150 points. And so you have 150 observations. I'm just taking some examples here. TAT model based, right? So again, here you have, let's say, 150 values, actual numerical values of time taken from the time a ticket was cut to the time a ticket was resolved. Here also you have, let's say, 150 values. Okay, so let's call this data set. I'll just name these data set something sensible. So let's assume this data set is D manual. I'm just making it up. Okay, this is D model, right? You simply have 150 values here and 150 real values here. Now what do you do from here? Okay, somebody is asking what is turnaround time. Okay, let me elaborate. Turnaround time is the time from which, suppose let's assume this is your time axis, right? Suppose this is the time at which somebody cut a ticket because they want to resolve a query, right? And at this time, let's assume it was resolved. This whole time is called turnaround time. This is the time it took for your technical team to turn around and respond to the customer's questions. Right? That's what is called turnaround time. Good question. If you don't know it, please ask. Okay, so So this is a good question from Salman. He says, are we supposed to give these quantifying improvements without trying it? No, no, no. So again, you can, so let's assume the vice president asks you what is the business impact, and you can give some metrics of the model, right? You can say, hey, I have so and so metric that I measured on how well I can assign these. So I have this test metric and train metric. But a vice president who may be non-technical, who may be a business guy, may not care about these metrics, because these metrics are what you came up with to address this problem. What he cares about is the actual business metrics, the actual business impact. So it is completely conceivable and understandable, and you can tell him, boss, of the 1,000 tickets, I want to conduct a test like this, which is like a standard A/B test, where 150 of them, I will send it through the model-based system because we think it is better. Okay, rest 850 are still going through the manual system itself. So by doing this, there is very little business impact in case the model-based system is terrible. Imagine if this was bad. Okay, suppose instead of assigning a ticket to, let's say, person 1, it is always assigning it to person 3 who can't answer this, who has to again figure out something, takes time, again reassign it to person 1, right? Or again say that, hey, I can't resolve this, assign it to somebody else. All that headache will be there. Okay, so that's something that you have to keep in mind. Okay, so again, you want to de-risk the experimentation cost, because if you did a 50-50 experiment, probably the model is terrible because of some problem. So you don't want to do very large experiments. You want to start with smaller experiments and then keep increasing the size of the experiment. Okay, let me hear your thoughts here. So Ananya, what is A/B testing? Unfortunately, we cannot explain you what is A/B testing in this context because that will take us considerable amount of time. Again, for this, the prerequisite that we assume is you know the basic statistical techniques, basic machine learning and deep learning techniques. Unfortunately, it will take me easily 15 minutes to give you the intuition behind A/B tests. Unfortunately, we don't have bandwidth. Okay, but once you learn A/B test, please come back and revisit this. It will make a lot of sense. Okay, some of you are suggesting benchmark test. Okay, so let me read through a couple of this. Okay, so two-tailed hypothesis test to see if TAT manual and TAT model are same or they are different. Interesting. Okay, so now what you're telling me is, okay, so you have these observations. Now we are going to do a hypothesis test and say, okay, that's a nice point. So what you're going to tell me here is your null hypothesis, right? You're doing a standard hypothesis test, right? And you're saying, hey, your null hypothesis is the turnaround time for model is very similar to turnaround time of, model is same as manual. Okay. Your alternative hypothesis is the opposite of this. They're not, right? And then you'll do a two-tailed test. But what sort of test will you use here? What sort of test will you use here? There are two things. What test will you use here? That is important. That's the first question. And what is the significance level that you will use? What is the significance level that you will use? Now, there is one problem with this again. I'm just trying to tell you the real world challenge. Let's assume you did some testing at some significance level of 5%, whatever it is. You conclude that TAT model based is not equal to TAT manual. Let's assume you conclude this. Or let's assume your null hypothesis is slightly different. The TAT model or turnaround time of the model is less than turnaround time of this thing. So you do a hypothesis test. This is only confirming that they're not same, or if your null hypothesis is slightly different, you can say the turnaround time of the model is less than the turnaround time of the manual system. But this is still not quantifying the results. It is saying, hey, with so and so confidence or with so and so significance level, I have done a statistically valid hypothesis test and I know that this is less than this. But by what amount? Right? I know that they're not equal. That's okay. That's good. But how much is the business impact? I want to quantify, because if you've done a good job at this, I want to give you a hike, right? Or I want to take this product to a larger audience, right? So while hypothesis test is good to confirm whether the values are the same or not, it is still not sufficient in this setup. It is still not sufficient to quantify the result. Okay, so the question is this follows. Okay, again, just to clarify, the question is, you have done your A/B testing, you got 150 observations of turnaround time of the manual model or the manual system and the model-based system. Now, using this data, how do you quantify and write a report saying, hey, by using the model-based system, we are saving this much time? How do you quantify those results in a statistically significant way? So hypothesis test can confirm that the turnaround time of the model-based system is less than the turnaround time of the manual system, but it still cannot quantify in this setup. Okay, so one of you is suggesting use bootstrapping. I'm just writing all the interesting ideas, right? Again, there is no one right answer here. There are many right ways to do it. Use bootstrap to get the number. What number? What is the number that we are trying to obtain here? So somebody says, can we use p-value to quantify? Like every hypothesis test has a p-value, right? And you test and you compare the p-value with the significance level. So p-value is what is the probability of observation under null hypothesis, right? All that is okay, but that still cannot numerically quantify the result. Okay, this is an interesting thing. So what some of you, just let me quickly scan through it. It's hard to scan through and also think parallelly, but I'll try to do my best. Okay. So what Rajesh is suggesting, very interesting. So he's saying, okay, let me just write it here. So what Rajesh is suggesting is that we will do a bootstrapping based method to produce confidence interval on turnaround time manual. I'll just write it as turnaround time manual, and also confidence interval on turnaround time model based. Now, what is it a confidence interval on? Because look at this, the turnaround time manual, there are 150 values, right? There are 150 values here. Look at this. In this A/B test, we have 150 values here. We have 150 values here. For what are you providing the confidence interval on TAT-MA? So you're saying mean. Okay. So you're providing the confidence interval on mean TAT, confidence interval on mean TAT. Right? There's a problem here, right? Again, I'm just trying to simulate a real interview. The problem here is means can be very cumbersome, because let's assume there is one ticket in the manual system which took too much time because it's a type of problem that nobody encountered. Of these 150 problems that we have, of these 150 tickets, let's assume in a manual system there was one or two issues that got randomly assigned here, which we have never seen, which took days to resolve, right? Then wouldn't mean get impacted by that? So mean is surely not a good metric, because you could have one outlier TAT, outlier turnaround time, isn't it? So mean certainly is not a good idea. Also, somebody is suggesting median. Okay, obviously that's like a simple extension. So you're saying using bootstrapping, you will compute, again, I'm just taking one path here, please bear with me. So using bootstrapping, you'll compute the confidence interval on the median TAT manual, confidence interval on, let's say, median. Okay, so you'll also do medians here. Okay. Yes, using bootstrapping, you can compute any quantile, any percentile, median being the 50th percentile. Okay. Now here is another issue. Now, is this sufficient? Is this sufficient to write your report? This is certainly a good metric. You can say, now there are more problems in this, which is, let's assume this is the confidence interval. Let's assume this is your x-axis. This is your, okay, so let me write it down. Suppose this is your median TAT manual, right? So let's assume this is your, this is the confidence interval. This is a 95% confidence interval. Let's assume this is a 95% confidence interval of median TAT model. Let's assume you plotted the actual data and this is what you got. Now, what will you tell your vice president? You did your whole bootstrapping, that whole exercise on the medians. What will you go ahead and tell your vice president now? Like, what is, suppose if this is the result, what is it that you'll write in the one pager? Again, this problem is specifically about measuring actual business impact. That's the whole objective of this. If we have less data size, in that case, outlier removal, how will it affect on model learning? Again, there is no model being trained here, right? We're just doing simple statistical analysis. Yes, this video will be available on YouTube even after the session is over. So don't worry about it. In case you don't know some of these concepts, you can always revisit them later. So again, I just went through one of the paths that you guys suggested, which is also one of my favorite paths, which is to use a bootstrapping metric. To use a bootstrapping to compute metrics. Okay. You can say the median time. So let's assume there is some gap between them, right? So you can go to the vice president and say, hey, like what is the number? See, he is looking for what most business folks care about is quantification, business quantification. Okay, for example, I'll tell you what most vice presidents and others would like, because I've reported to some of them in my past at large corporations, and they would like to see something like this. Okay, by using a model-based system, we saved, our turnaround time reduced by some 10%, resulting in cost saving of some 6%. Right? So, or you can say, hey, my turnaround time reduced by 10%. But of course, you can't get a singular value very easily. You want to do a more thorough analysis. You want this number that you produce here to be statistically sensible. Okay, so the business folks, again, remember, the business folks are not dumb. They have studied statistics in their MBAs also. Some of them are actually engineers and they know the heck out of these numbers. So they know some of these things. They know what a median is. They know what is a 90th percentile. They know what is a mean. They know what is a standard deviation. They do know that. Okay. So they want a quantification. If you just give this plot, they'll have to still struggle to make sense out of it. Like, what will be the top line summary that you'll write in your one-page report? Percentage reduction in turnaround time. How will we measure that? That's the question here. That's what we want to measure. We want to say, hey, the turnaround time of the manual system is X% more than the turnaround time of the model-based system. The median confidence interval could be overlapping in the real world. Oftentimes they will overlap. Let's not. In the real system, this happens to a lot of A/B tests. Okay. Okay, so what one of you is suggesting, which is not a bad idea, is saying, hey, let's not worry about all this stuff. I will just take the median turnaround time of the whole manual system minus the median turnaround time of the model-based system, and I'll just convert it to a percentage value, right? I can easily convert it and say median turnaround time of the manual system and say, hey, if you just look at the median metrics, then we reduced the turnaround time by some X%. Good. This could be a top line summary. Again, whenever you're writing a technical report or a business report for a VP, it's always good to have 1, 2, 3, 4 points at the start. Like, even if they don't have time to read, thankfully, when I worked at Amazon, I learned how to write good 1-pagers and 6-pagers, right? So in the first 2 minutes of them reading your document, you want to say, this is the 4 key takeaways for you. And here is all the analysis and data to justify these 4 conclusions. This is a great way for them to make an impact and say, hey, this is what you can take away from this. Okay. So my question here is, one of these, like the median turnaround time reduction, could be one metric. Perfectly valid, right? What else can we do here? Okay. So when you're doing this, right, there is also this risk. If these, like, look at this. So this value minus this value. So what we're doing here is we are just comparing this gap and we're saying this much we've increased. But if the confidence intervals are very wide, that is a problem. Like, if your sample sizes are small, look at this. If your sample size is small, the confidence intervals will be wider, which means the chance that they will overlap also will be wider. Right? So ideally what you can do here is you can say, hey, within the limited experimentation, in the details you can say, within the first cut experimentations that we have done, these are what we have observed. Please give us permission to do a larger experiment so that the confidence intervals can be tighter and we can quantify it better. Fully sensible, right? Cool. Okay. Okay, so I think this went in a good direction. Just like median, right? You can also summarize and say just like the median reduced by. Okay, so there are multiple ways of writing this. First metric, you can talk about the median reduction, or the reduction in median. The second thing you can say is the extreme cases, the number of cases or the number of instances where, let's assume you have a 24 hours SLA to resolve these issues, right? Or to resolve these tickets. You can say in the model based system, okay, let's assume 1% of tickets took more than 24 hours. In the manual system, this was 2%. So relatively speaking, this is half of this, because people care, because you've promised your customers that you'll solve questions or you'll resolve these tickets in 24 hours. So this could be a second metric. Again, even this you can get this data. This data may not be statistically significant when you're operating only on 15% samples, but you can say within the limited data that we have, this is what we observe. Please give us permission to go from 15% to something like, let's say, 30% here. You should, in your A/B test, start with small percentages, get directional value and keep increasing this. So then this will become 40%, and slowly your whole model based systems proportion of the traffic will keep increasing, right? This is how you can actually quantify the results, right? I hope this was an interesting question for you. You're right. Wazir has a very good point that that point estimate based systems can be erroneous. You can make erroneous conclusions from them. That's very true. So that's why at the top line you can say this is what we have with the limited experimentation that we have done, and you can also show the confidence intervals, and you can say, hey, the confidence intervals do overlap significantly, hence we want to do larger experimentations. That's why I was very happy when somebody suggested that we should take confidence intervals using bootstrapping, because point estimates can be very, very misleading in the real world. These confidence intervals will like tomorrow, suppose you did this experiment with 15%, and you saw some 10% improvement in the turnaround time. You're setting a very high expectation. If you don't show these overlap of confidence intervals, tomorrow you do the experiment on 30% traffic and you see a lift of only 5%. So you should always back your data and tell what could be confusions you could have or what could be problems in these point estimates in more detailed technical report. That's a very good point, Wazir. That's a very good point. Okay. Okay, I think this is good. So this was a good question, right? Again, this is an easy question. This question is primarily testing. Can you think of metrics? Can you think of how do you do A/B testing? Can you actually measure business impact? This is a very important question that a data scientist should know how to tackle. Okay, in the interest of time, let's go to the next question. Okay, so let me elaborate this question. This is about simple linear or logistic regression models. So you're given a data set D of 100 million data points. Again, M means 1000, basically 1000 into 1000 is a million. Okay, so you're given a data set of 100 million data points, and each data point is a 1000 dimensional data point. Okay, this data lies in a 1000 dimensional space. Now you want to fit a logistic regression model on your PC, and your PC only has 4 GB of RAM, and it has an entry level processor like an i3 processor. Okay, now the question is this. Note that the size of the data set, right? The size of the data set is significantly more than 4 GB. Now, how will you train the best possible model, or very close to the best possible model, or approximately the best possible model on the data set D given these engineering constraints? This question is an easy to medium question. The reason I said easy to medium is because, I mean, some interviewers are just expecting high level answers. Some interviewers can go fairly deep into this discussion. Like I've been part of interviews. I've also talked to a few of our advisors who ask a variation of this question, and they can spend half an hour just going deeper and deeper and deeper, giving you counter examples, giving you counterpoints, trying to understand how deep and how well you understand the actual computational challenges of training models. Okay, so this is the question. Read it and let's see what you have to say in the chat window. So somebody is saying that I will use Dask. Okay, so the moment somebody says I will use Dask, if you're especially interviewing at a product-based company, they'll ask you, please tell me how Dask works internally. If you don't know that, you better not say it. Okay, because then the interviewer knows that you're just throwing some terms at me without knowing what you're throwing at me, right? So please understand, like whether you can say Dask or H2O, you better understand the internal architecture. The immediate question that I'll ask if I were the interviewer is, okay, how does Dask solve this problem? Can you elaborate on the internal architecture of Dask? That's the first question, right? Or somebody saying Spark ML. Remember, all you have is an i3 processor. I don't know, I think i3 processor has 2 cores and 4 threads, if I'm not wrong, right? Your RAM is still limited. Just running Spark or H2O will literally kill your system, right? Even the overhead of running Spark or H2O itself is humongous. Okay, let me see. Okay, just let me keep, I hope the question is clear. So let me just write all of your thoughts here. So, first thing that somebody suggested is Dask. Okay, you should be comfortable with the internal architecture. And those of you who suggested Dask, can you tell me how Dask helps you solve this problem with a few details on the internal architecture? Number one. Others have suggested Spark and H2O. This won't work. This basically means that you don't know how Spark and H2O works. The overhead of running your Spark server or master node or H2O master node itself is so humongous that your whole system will slow down. So this won't work. Okay, let me just see others that you're suggesting. Okay, so another interesting suggestion is feature selection. Because we have 1000 features, can we do some feature selection? Remember, your data doesn't fit into your RAM. So how do you do feature selection in this setup? Please elaborate. Others are suggesting stratified sampling. Okay, stratified sampling. So my question for you is, how do you do stratified sampling when the data doesn't fit into RAM? Please elaborate. Somebody is suggesting threading concepts. Okay, how will you use multi-threading here? Okay, so just let me write everything here. Let me use a slightly different color here. So people are saying that I'll use multi-threading and multi-cores. How will you do it? Your data itself doesn't fit into the RAM. Okay, please elaborate. So somebody is suggesting dimensionality reduction plus batch processing. I'll come to batch processing in a minute. So how will you do dimensional reduction? Let's assume you want to do PCA. For PCA, you have to take the whole data matrix and find eigenvalues, eigenvectors. How do you do it when you can't even load the data? Forget about loading the data. You can't even compute similarity matrix now, right? How do you even do PCA when the data doesn't fit into RAM? Okay, so I'm just going quickly, scanning through all the options. Somebody is saying, can we do SVD? You can't do PCA SVD when the data doesn't fit into RAM. There are other variations, but you have to explain me how to do that. That's the question here. Train on chunks and use transfer learning. Okay, so train on chunks. Okay, chunk-based training. So how do you get these chunks? That's the next question. How do you get these chunks? Now, transfer learning, there is, okay, I didn't know what you mean by transfer learning, but please elaborate. Google Drive. I said the question is very clear. Let's assume this is some company data that you can't transfer to Google Drive or any other computer. You have to do it on your own laptop with limited resources. How do you solve the engineering problem? Okay. Cool. Chunk-based training. Okay. So I think what one of you mentioned with respect to chunk-based training is you will load data from secondary storage, which is your SSD or RAM, sorry, SSD or hard disk. So you will load data in chunks from, let's say, HDD or SSD to your RAM in chunks, right? Okay, perfect. This is how all file handling works, right? Whenever you're reading anything to file, the way file handling works internally, because this whole reading data from hard disk or solid state drive to RAM is managed by your operating system. The way operating system does is, let's assume you have a big file. Again, this whole data may be in one file or multiple files. That's an engineering thing that you have to think of. Whatever it is, if you load this data into RAM, it will load whatever it can in the swap space and in the RAM itself. Okay, fair enough. This is done. So let's assume only some 5% of data is loaded into the RAM at any point. Okay, then what do we do now? So somebody is saying Dask basically chunks the data into smaller parts and loads it into RAM. That's what any file management system does. If you go and read about Linux file management also actually does this using the standard operating system methods and how your whole HDD or SSD is designed internally, right? You have blocks and things like that. If you have studied operating systems at undergraduate level computer science, that's what actually any file management system does. What is special about Dask? That's a question now. So somebody says, okay, so this is interesting. So somebody says we will break the larger data. So let's assume this is my big data D. We will chunk it into smaller parts, and I can do it by just loading chunks of data into my RAM. So let me just draw the diagram here quickly. So let's assume I break this whole data into smaller chunks. Okay, let's call this data D1, D2, D3, so on and so forth. Let's assume there are 20 chunks of data. So on D1, you train your model and you do something called as a partial fit. Okay, so somebody is saying I will do a partial fit, right? And then, okay, can you please elaborate how partial fit works internally and how will you now train it with D2, D3 up to D20? Can you please elaborate on that? Because I'm looking for the internal working of how this works. So somebody says, can we use random forest for the selection of features? Now the problem here is you can't use random forest because to train random forest in most instances, you will first need to load the data into RAM, right? Without loading the data into RAM, how do you train a random forest? That's a follow-up question there. Okay. Okay, so somebody has an interesting suggestion. Let me tell you why it won't work. So somebody says that we will randomize. So let's assume this is my big data matrix. They will randomly select columns, right? So randomly select columns. They will also randomly select rows, right? And they will train multiple models. Let's assume they train model 1, they train model 2. They'll randomly select as long as the data fits into your RAM. Now the first question here is, how do you randomly select columns and how do you randomly select rows? Because this data is actually on the disk. This data is not in your RAM. If it is in your RAM, it's very simple. You can say, let's assume this is in a pandas data frame. Then it's very simple. If it's on disk, how do you randomly sample columns? Okay, that's a challenge. Randomly sampling rows may be easier. Actually, sequentially sampling rows is easier. Randomly sampling is still a little cumbersome. Well, it's possible, it's not trivial. Okay, so that's the first question that you have to solve. The second question for you is, if you're training multiple models and you said, hey, I'll take the best performing models, let's assume M1 and M3 best perform, then how will you combine these models now? That's a problem, right? You said, I will just pick the weights which are most occurring, but it could so happen that these weights and these weights, the weight vector and the bias vector that you get here, the weight vector and the bias vector that you get here in logistic regression could be different, right? It need not always exactly be the same. How many classes are there in the target variable? Good question. Let's assume it's a binary classification for simplicity. Good question. Okay, so somebody is suggesting, okay, so for partial fit, they're suggesting we will do a mini batch. Okay, so let me write it here. So they're doing a mini batch SGD. Okay, so you do a mini batch SGD. Suppose let's assume D1 has some 5% of points, right? Again, this whole data set is stored on the disk and you took the first 5%. You trained a mini batch SGD. Suppose you got model 1 now, right? But the question here clearly says, train the best possible model on dataset D. What you're training here is only on the 5% of data. Do you think M1 is the best fit model? If so, why? If not, why? Think about it. So somebody is suggesting a nice thing, which is, let's assume I train multiple models. I'll take the mean weights. That's a good idea. But before you even go there, how do you randomly sample columns and how do you randomly sample rows? Because your data is actually on the disk. So somebody is suggesting ensembling. How do you even build an ensemble model here? We are not able to build a single model. How do you build an ensemble? And our objective here is to build a logistic regression model, not an ensemble model. Please see the question carefully. Now somebody suggested, okay, I'll train multiple models and I'll take the mean weight and the mean bias vector. Great. But before you do that, how do you randomly sample columns and rows? This data is not in your main memory. It's not in your RAM. It's not in your pandas data frame. A lot of it is sitting ducks in your hard disk. So Sachin is saying that, okay, so let me write this, right? So Sachin is saying randomly sample points from the disk, train a model, let's assume M1, you write it to disk. Okay, so you write it to disk, and then what does he say? Okay, and then shuffle the data. Okay, and then shuffle the data, again randomly pick and then update this model. Great idea, but how do you randomly sample from disk? This is the first question. Again, somebody suggesting Dask plus SGD plus partial fit. Please explain me how Dask solves this problem internally. You're right that partial fit, SGD, those are good ideas. I completely agree. Mini batch SGD, partial fit, that's what it does internally anyway. But I'm looking for how does Dask solve this problem of randomization? So Arun has a nice idea. Arun says, okay, sorry, let me not write your name, but it's an interesting idea that you said, but it has a problem of its own. Okay, so again, these are all actual engineering challenges. Suppose you have this large data set. Let's assume this is your whole data set that is on disk. Again, I'll write it very carefully. It's on your hard disk or solid state drive. Okay, so he's saying, so let's assume there are some n points here, right? And some m columns. So he's saying I will randomly generate some numbers between 1 to n and pick that data and load it into my RAM, right? Randomly pick rows. Now the problem with that, Arun, is how do you, like, this data is fairly large, right? Again, I don't know if you have studied computer science at undergraduate level. Whenever you're reading from a large file on the disk, in most operating systems, the way, okay, so let me just give you a primer on how it works, just to clarify that, okay? So whenever you try to load data, not randomly, suppose when you're trying to load data into the RAM, the way most operating systems, especially Unix based operating systems, work is they actually break this whole file on the disk into something called as blocks. Okay, so this is one chunk of block which is stored in one contiguous location on the disk. The next block could be located elsewhere on the disk. So everything is logically broken down into something called as blocks. The size of the block depends on the operating system and its internal architecture. So when you open a file handler, right, whether through pandas or simple file handling, what happens is typically one block of data is loaded into RAM. Only one block of data at any time. Now in your process, because you're saying, hey, I will randomly generate this data, right? I'll say, hey, pick up one row from this block, pick up the next row from this block, pick up the next row from this block. Randomly you're generating it. Your whole system will simply come to a standstill because the cost of reading these blocks from a disk to RAM will simply make your whole system hang up. It will be extremely slow. Okay, this is like a 2-minute primer on how files are organized in any operating system. Again, whether you're using Dask or whether you're using any system, you still depend on the operating system's file management system, which is what does all of this internally for you. Okay. Again, this is something, especially if you're working at a product-based company or if you're interviewing for a product-based company, and if you come from a CS background, this is the depth that you should expect the interviewer to go to. Okay. Okay. Let me see each of your questions. Can we do bootstrap sampling? It's not that easy, right? You can't even do random sampling. Okay, let me see through some of the other suggestions. Okay, why can't we keep training on the model on incoming chunks? Okay, so this is an interesting idea. So what? Okay, let me see who said this. This is Vamsi. Vamsi is saying, I will take D1. First, I load, let's say, the first block or the first set of blocks. I will train my model M1, and I will remove D1 from memory. I'll just clean it up, right? Then I will load D2, right? I will load D2. I will keep updating this model now, right? Cool, very nice idea. So the idea is, okay, so let me just go here. Let me write it down for you. The idea here is, if this is your whole data, he's saying, let's go sequentially. Let's go block by block. Let's go chunk by chunk. So you have, let's say, model 0 first. This is your first chunk, second chunk, third chunk, let's say 20th chunk of data. So your initial model, randomly initialized model, after you train it on the D1, let's call this D1, let's call this D2. Let's assume each of these DIs fit into your RAM. Okay, you break it into the chunk size such that it comfortably fits into your RAM. So let's assume this is some 2 GB. If you have 4 GB RAM, it will comfortably fit. You take your initial model, you do mini batch SGD, standard stuff, right? You implement your own SGD from scratch, or you use scikit-learn's partial fit. At the end of going through all these points, at this point of time, you get model 1. Okay. If you want, you can store it to disk just in case your system collapses or it breaks down at some point or it shuts down. Then you load D2, right? You load D2. You keep updating this model M1. So when you're training on D2, what you're doing here is you're starting with the weights that you have, weights and biases that you have with model M1. At the end of it, you get model 2. So on and so forth, you keep doing it till model 20. This is a good idea, simple idea, fairly straightforward idea, right? Good. Now comes the next interesting question. Okay, so the follow-up question is as follows. Will you do all these 20 models? Look at this. If you have model 1, so what you're doing here is you're going through your whole data, your whole 100 million data points where each point is 1000 dimensional. You're going through all of it, which could take days. I mean, depending on how optimized your code is, this could take few tens of hours to maybe even days. Now, is it necessary to get a pretty good model? Is it necessary to train on this whole data? That's a follow-up question. Can you somehow optimize this? The hint that I'm giving you here is, do you have to train all these M1, M2, M3 up to M20? How do you determine whether you need to train or you don't have to train? Okay, good question. So somebody asked, what is the file structure? How is this data stored? Let's assume it is stored as a flat file, like a simple CSV file. Okay, I mean, I'm just taking you to the hardest case. Of course, if this data is stored in an indexed file, right, the way most databases are stored, let's assume, for those of you who come from CS background, let's assume this is stored in a database using a B+ tree, right, or some sort of system like this. Then you have some advantages because B+ tree internally uses all these optimized structures, right? But let's assume it's not. Let's assume it's a simple flat file. You don't have an indexed file to start with. Again, building the whole database index and all will take considerable time because you have 100 million data points. Okay, interesting. So this is what we are doing. Okay, somebody has a nice suggestion, which is he's saying, so instead of training M1, M2 incrementally, right? So you start with your initial model, right? Which is your M0, which is like a random model. And you keep going on till M20. So what one of you, I think Rajesh, if I'm not wrong, yeah, Rajesh is suggesting here is just stop at MI as long as the cross-validation error is good, right? Now the problem here, Rajesh, that I have here is, well, this is a good practical solution. Okay, so as long as you know that, okay, anyway, for training, you will have some cross-validation data, you will have some test data, you'll have all of that standard setup, right? You're saying, okay, if the metrics on cross-validation and test data are good, let's stop it. Let's not waste any more time. But if I were your manager or if I was your colleague, I could argue that, okay, this is good. So let's assume you're getting an error. Let's assume it's a simple error metric, right? Let's assume we are getting an error of 2%. Then as a colleague, I might say, hey, 2% is good. But the actual business impact is significant if you can get it to below 1%. Right? 2% is acceptable. It's okay. But getting to less than 1%, or maybe let's get it as small as possible. Then how do you now answer me and say, hey Verma, this is cool, but we may not be able to go anything below this. Cross-validation, all that is there. Very nice, very nice. I think this is Prem who suggests that if the weights are not changing much, if the weight updates, very nice point. If the weight updates have saturated, very nice point, very, very good. So when you're training these models incrementally, if the weight updates haven't changed, if the weights are not changing much, right? If the weights are only changing by a very, very small percentage, just don't worry about the rest of it. Again, here we are making a very fundamental assumption that the data that is there in the original file is IID. I'm talking statistically here. So we are assuming that the data here is not in any time order or anything. Then everything can be messed up. So you have to be careful. We are just assuming that the data is IID and it is already randomized internally. That's a fundamental assumption that we are making here. Otherwise, this method will not work. Let's assume there is some time ordering in the data. Then this method may not work. That's the next complication that we can add to the problem. Good. This is a very nice idea, Prem. What else? What else can we do? Train M models on the subset of data and the weight vectors don't change. Yeah, weight updates have saturated. Good point. What else can we do? So somebody is saying, let's say if the model is not improving after training till M7, this is nickel, then we can stop training. How do we come to that conclusion? Can we use skipping data while reading? It is possible. You just have to use some of the check whether the loss is minimum. So Vamsi, to answer your question, you can stop when the error is not decreasing any further. Yes. So one simple nice visualization that is often used here is, this is the data size, right? You can do this very interesting plot. This is, let's say, model performance, whatever performance metric that you're using. A very common strategy that a lot of people use to say, hey, there isn't much value by increasing the data size. Again, here we have the model. Our model, remember, is a logistic regression model, which is not a very complex model. The number of parameters are limited here. The number of parameters is the number of dimensions. There are only 1000 weights and one bias. It is not a very heavy model or a very complex model. It's a fairly simple model. So what will happen, because you are training a logistic regression model, is as you keep increasing your data, let's assume this is data 1, data set 2, data set 3, so on and so forth, data set 20. In addition to looking at model weight updates, you can also say what is the model performance on cross-validation data, or better still, the test data. If you'll most likely, especially for logistic regression like models, you'll say for D1, the performance will keep increasing, but beyond a point, it will saturate. It will not increase much. So probably this is, let's say D4. With D5 and D6, if you have not observed significant improvement, then you can say, hey, the performance has also saturated. There isn't much of benefit. All the benefit that we had, we have gotten it here by just looking at the first 3-4 data sets, or first 3-4 chunks of the data set. There isn't huge advantage of going any further. So let's stop it here. Again, here comes the more interesting angle. This question can be further complicated and made more interesting by saying, hey, what if this is not a logistic regression model, but let's say a multi-layered perceptron? Then the problem becomes more interesting, because the moment I have a multi-layered perceptron, I can keep increasing layers. I can keep making the model more and more complex, right? Again, in a logistic regression case, the number of parameters are small. In a multi-layered perceptron, I can keep increasing the layers, and by increasing the layers, again, it's standard hyperparameter tuning, because the number of layers and number of neurons is also a hyperparameter for your MLP. There again, you'll see as you keep increasing the complexity of the model, what is happening to your model performance. At some point, it will also saturate there. Okay, but this is a good question on, again, the direction is fairly simple. This is mostly a simple question, but it can be made a medium difficulty question by going into the software engineering details. Okay, again, very nice. Someone else has asked a very nice question, which is, okay, so let's come to that point. So somebody said, why can't we do feature selection? There is a fundamental problem with feature selection, right? Which is, if your data is stored in a row major form, suppose you store it in CSV, let's assume, okay, so let's assume your data is stored in a CSV or a TSV. There is a problem in feature selection here, right? So the problem here is, this is your, let's say, data point 1, row 1, then row 2. This is a very, very large file. Now, the challenge here is, how do you extract, let's say, feature 10 from all these rows? Because what happens is, this chunk of data is in one one block of your operating system's file system. This is in another block. So just even to do univariate analysis, when the data set is very large, even to do simple univariate analysis, you need all these values along with your, of course, yi's, right? You need along with these, even for simple univariate analysis, you need that to discard some of these features. But loading all of them is prohibitively expensive, because this is in one chunk of your disk, or to be more precise, this is in one block of your disk, this is in another block. You have to load all the blocks, and you can't load more than a few blocks into your hard disk at any point. So your hard disk will throttle a lot if you try to do it. So a better solution is, since you're anyway training logistic regression model, it is better to just have, okay, where is our logistic regression model? Okay, since you're anyway training logistic regression model, a better strategy is just have L1 regularizer, so that all the useless features will be made to 0. One other very interesting hack that you can do here is this. Suppose you train, let's say, on D1 and D2, you see some of the features weights becoming 0. Discard them when you train D3 and D4 and so on and so forth. Because you have 1000 features, most likely only a few hundred of them might be actually useful, rest of them useless. So by having L1 regularization, after you train model 1 and model 2, you can look at the weights which are very close to 0 or which are actually 0 and throw them out and say, hey, I'm not going to process this and just waste my time in the future. So you can do feature selection and elimination in this sequential system implicitly, right? I hope this is helpful. Okay, Saurabh says we can convert this file into paraquet or into JSON file. The file systems don't change. At the end of the day, you're sitting on an operating system file, right? Again, the moment you suggest something like a paraquet format, the interviewer will say, okay, how does a paraquet format of file system solve this problem? You have to understand the design, the internals of it. Okay, so if it is doing some indexing, again, depending on the company, depending on how much the interviewer knows, he can go very, very deep. Okay, cool. How do you read the data chunk by chunk? That's actually straightforward. If you use standard file processing functions in Python, it actually reads it block by block. It does it implicitly. The operating system, I don't know about Windows because I've not used it, but all Unix based operating systems, this is how internally it works. I'm 99% sure Windows also does the same thing. Okay, so it reads a block of data, and if there is not enough space, it will remove it. This all happens internally by the file management system of the operating system. So I'm sure Pandas does it internally implicitly for you. If you just do simple reading CSV file using Python read.csv type of functionality, it also does this internally, right? So you don't have to do anything explicitly, but knowing how it works internally is very helpful. Okay, cool. So Srikanth is suggesting, can we convert the data to TF records? Again, it will not help you much. It's the same problem that you'll run into even with other formats of data. Even if you're trying to convert the data to other formats like an indexed file or a paraquet file, the time it takes to transform this whole data into a new format will be prohibitively large. Let's not forget that. Okay. Okay, sure, this is looking good. Good question. Parithos has a question. What if we are training a GBDT instead of a logistic regression model? That's where the problem becomes interesting. Okay, unfortunately, we have already spent 1 hour, but take it as a good assignment problem. Okay, you can please write it in the comment section later after this live session. How do you train a GBDT if you are memory constrained and processor constrained? That's a nice problem to think of. Okay, cool. So let's go to the third problem now. Okay, so this is an interesting problem. Okay, suppose you're training a linear regression model and you have some data set. You train R square. This is the coefficient of, what is it called? Coefficient of determination, I think. I keep forgetting these names. The R square metric, right? The standard R square metric, which is, so your standard R square metric, right? So how do we do the standard R square metric? We have 1 minus SS residual by SS total, right? This is a standard formulation of R square metric. This is what I'm talking about. Okay, so your train R square is 0.95, very good. Your test R square is also very good, right? Things are looking very good, right? Now the problem that you have here is, even with all of them, okay, so by just looking, let's assume your model's metric is R square. The R square metric, the best value that you can have here is 1. because it's 1 minus some positive value, right? The best value you have is 1. So it's doing very good. But what you have observed here is when you actually look at yi values and yi hat values, when you take the difference between them, these differences, or these are also basically your errors, your absolute values of errors. You've trained a model, right? You've trained a model. Because you have a model, you can get yi hat, which is basically the predicted value by the linear regression model. Okay. So the errors, the absolute value of errors are still large. They're not small. How is this possible? How do we fix this problem? The R-square metric looks very good, both on train and test data, but the errors seem to be large. When you actually when you actually plot the errors, it's standard error analysis that you'll do, right? You're not happy with the errors. Okay, how is this possible? What is happening? What is happening wrong here, and how do we fix this problem? Again, this problem is a medium difficulty problem because this problem requires you to think deeply about the R-square metric and linear regression and debug what is happening. Slightly tricky, but very interesting. Again, a problem like this could happen even with normalization. I can construct examples. High variance in data. Can you elaborate, please? Can you please elaborate this? Okay, let me write what you guys are saying here. I'll just keep writing all the key points and keep coming back to them. So some of you are saying high variance in data. Can you please elaborate and give me mathematical justification? So again, let me just write the equation for R square here. Your R square metric is 1 minus your SS residual by SS total, right? So can you give me a justification, or can you construct an example where this happens? Okay, if you have lot of outliers, very nice, very nice. So some of you are suggesting, very nice, I'm happy you got it. Very nice. Outliers, some of you are also suggesting a solution, which is you can use log of the values. Very nice solution. Very nice. This can be, okay, this can be an indication of the overfitting or a complex model. We should also look at other metrics like adjusted R square, etc. Good point. Good point. Okay. So as some of you are suggesting, again, can you please explain more mathematically, please, if you can? One of you has suggested that SS total is very large. Can you construct an example where, like, while some of what, again, there is a problem in most interviewers are very careful because this is a well-known problem about R square. What lot of candidates probably have read it somewhere, and they'll simply say there's a problem of outliers. So the interviewer, especially at good companies, will say, hey, please construct an example and show it to me. Okay, tell me why exactly mathematically this problem is happening. Again, so we'll see how to fix it. Okay. So somebody has rightly said, Rajesh has rightly said, and also others, which is SS total is very large. Okay. Okay. Highly skewed data with lot of outliers. Okay. Good, good, good. Okay. Unfortunately, in here, unlike our Slack, actually people can draw diagrams and upload them. Unfortunately, here we don't have that advantage. Okay. Can you tell me more? Feature scaling could be missing. That's possible. Yes. As we use mean to compute SS total. Very nice. Good point. I mean, I'm looking for these. Unfortunately, in an actual interview, the interviewer might say, hey, please draw a diagram, explain me visually and things like that. So what is your SS residual? SS residual is basically summation over yi minus yi hat squares, right? The summation of these. And the denominator is summation over yi minus y bar square, right? Y bar is basically the average of all the yi values. This is like your dumb model, as somebody rightly said, right? So if you have outliers in your data, what happens? Your mean would get impacted, and this denominator can be significantly large. So let me try to construct an example here. Again, I'm just trying to construct a simple two-dimensional example. Let's assume x is what I have here, y is what I have here. My linear model, my linear regression model takes x and tries to predict y. Again, I'm just trying to construct an example here. Bear with me. Suppose imagine most of my data is here. Again, I'm just trying to draw some perfect data, very linear. Let's assume I have some far away data here, which is like this. I'm just drawing some data here, and I also have the other side of the data here. Let's assume I have some data. Okay, I'm just trying to draw some data here. Okay, let's assume I have some data here also. This is standard your outlier data. Now, okay, because again the data, again your yi bar might be here, right? Sorry, your y bar. I'm sorry, your y bar may be somewhere here, right? This could be your y bar value, right? This is like the average of all the y values, because there are extreme positive values, extreme negative values here, right? Like these are positive values, these are negative values, and you have this. So your y bar is here. Now what happens? This is your y bar. Sorry. I want these values to be upper. Okay, sorry, my bad. Just a second. I wish I could, like, I have limited space here. Okay, so let's assume these points are somewhere here. And I'm just trying to construct the example here. Just trying to give you a sense of it. So let's assume these points are here. Okay. So the average, again, this average itself, where is this? Okay, this is my y bar. So what is your yi minus y bar? It is this gap. This gap is very large, right? So in your formula, what's happening here is for all these outlier points, this gap is very large, right? For these points, look at this, for these points, your y minus y bar is still small. So these points are not contributing much. Of course, there could be many more points here. I've just drawn a few. There could be hundreds of points here, right? There are a few outliers here and there. So what's happening here is these outlier points have a significantly higher contribution to the denominator. So the denominator is large. Now what's happening to your numerator now? Remember, the problem here is, okay, so you're still trying to fit a linear regression model. Okay, I'm just trying to construct an example and trying to show it to you visually. Okay, because you're trying to construct a linear regression model. Okay, let me use this. So what happens is, if these outliers were not there, your model will be a very nice linear fit like this. Because these outliers are there, it could so happen that your model is somewhat like this. Okay, somewhat. I'm just trying to construct an example here. If your model is like this, okay, on the other hand, imagine if your model was okay, I could have drawn this slightly differently. Okay, so let me just draw this for my satisfaction. Just give me a second. Okay, so let's assume. Okay, so now what's happening here is, if these outliers were not there, the model could have been like this. And if the model was like this, right? If the model was like this, right? The error contribution, the yi minus yi hat, because of this would be large, right? It is because of these points that yi minus yi hat will be large. So what happened is, because there are non-trivial number of outliers, the whole model got pulled towards the outlier. It got influenced because of the outliers. Okay. So what happened? You got your blue line like this now. Now with this blue line, the problem here is, for the outliers, it's doing a decent job. But for the actual data, for a huge chunk of your data, the error is still like, this is your predicted value, this is your actual value, right? The gap between predicted and actual value is still significant. So if you have a setup like this, you have a problem, right? So what are the solutions to this? Again, I'm just trying to visually explain you this. Again, it's exactly what you guys have said. But most interviewers will agree that if this is large, significantly large, then even though this value is like large, right? If this is very large, and if this is large, this ratio will still be small, and hence your R square will be still very good, very close to like 0.9s, right? That's a problem that you run into. Now again, the same visualization can be taken to higher dimensions with hyperplanes and things like that. Now what are the solutions to this problem? That is very interesting to think of. Okay, so let's write down the solutions to this problem. One solution that one of you suggested is take log values. Okay, so basically change the scale. Instead of using y, take log of y and fit a model on it. That's a good idea, because what's happening here is, then the range of these values is getting compressed. Okay, your yi values are from this value to this value now. There is a huge variability. By using log, you're compressing this range. That is surely a good idea, right? What other ideas can you do? What other ideas can you employ? Remove outliers. Okay, this is one idea, but let's assume there is a problem. Okay, if the number of outliers, okay, so there is a problem with removing outliers, which is, if let's assume the total outliers, suppose let's assume 5% of your data is here, 5% of your data is here. If you remove outliers and train a model, then the problem you'll run into is in the real world, because all of this training data is a sample from the real world, right? From your population. So what's happening here is your model will perform terribly on 10% of data. It will only, while it performs well on 90% of data using this white line model, on 10% of data, your model is completely messed up, right? So how do we tackle that? How do we tackle that problem now? Any suggestions? So this has a problem of, if you have 10% outliers, right? 10% outlier problem. Okay, any other suggestions that you can give me? Median absolute deviation. Okay, so you're saying you will use a median absolute deviation. There is a problem with this, right? The median absolute, how do you train a linear regression model? Remember, we are training a linear regression model, right? In the linear regression model, the error is squared loss, right? The error is squared loss. If you replace this squared loss is exactly like this, right? Squared loss is like this, right? So this is your squared loss. Instead of squared loss now, if you replace squared loss with median absolute deviation, if you replace squared loss with this, right? That's a problem because this is non-differentiable now. How do you optimize for median absolute deviation? It's computationally very, very hard. Okay, so this may not work. Again, this has problems of its own. Log is a good mathematical hack, but are there any other suggestions that you can give me? Reduce, can we use root mean squared log error? So using root mean squared log error is equivalent to, this is equivalent to taking log of yi's, right? This is exactly 1, which is equal to the option 1, exactly the same thing, right? So 4 and 1 are one and the same. That's what is happening internally, literally, right? Whether you change your yi values with log transform or you use root mean square log error in your optimization, it's the same story. Replace outliers. What will you replace outliers with? Again, outliers is also information sometimes. If 10% of your data is outlier, like imagine imagine you're trying to build some actual real world problem. Okay. Again, I've not given the real world problem here, but I've tried to pose it in a generic framework. If you're messing up on 10% of data, that could have severe impact on the business. Box-Cox transform is sort of like a log transform only, right? Any other suggestions? So log values is very similar to Box-Cox transform, because Box-Cox is like log transform is one of the cases of Box-Cox, right? So what else can we do? Regularization. By regularization, you will avoid overfitting, but it will not solve the fundamental problem here. The fundamental problem is 10% of your data is outliers. How do you tackle this real problem? Ransack. Again, you can use systems like Ransack to give a robust model. So if you use Ransack, you will get this white model. You'll get this white line here, or this green line that I'm drawing here, which will perform well on 90% data, but it will not perform well on the 5% of these outliers and 5% of these outliers. You want something that works in all cases. Again, you're just changing the metric here, right? By changing the metric, the model won't change because the model is still minimizing for mean square error or squared loss. Train a logistic regression on top of these features and apply regression. Why are you training logistic regression? It makes no sense, right? Because it's not a classification problem. We don't need a probabilistic interpretation of it now. Random forests. Okay, you can do some random forest. You can use more complex models. Let's assume we want to use a linear regression model. Now tell me, how will you solve it? There are some simple hacks that you can use here. Actually, they're used in the real world. Can we do squashing? Doing log transform is like squashing only, no? Polynomial regression. Let's assume we still want to use linear regression only. Normalize the data and bring it into fixed window. Even if you normalize the window, this problem may not always go away. And the reason being, what you're doing here is you're literally squashing, instead of this wide range, you're squashing these values through normalization. right? That doesn't avoid all of the problems, because if you're doing mean centering, right? If you're doing mean centering like this, right? The scale of the problem changes, which means your weights will change, your biases will change, but the problem stays the same. You'll still perform badly on these 5% outliers and these 5% outliers, right? You can still have the same problem. Power transform is same as log transform, Box-Cox transform. I've already discussed this. Can we use adjusted R square? Still the same problem might encounter. Think of practical hacks, folks. Think of practical hacks. I think one sensible thing that we got till now is this log transform, Box-Cox, those types of transform. Makes a mathematical formulation for data points outside IQR and then train a model. Very good, very good. Very happy to see this solution. So what, let me see, who said this? I think Rajesh Dhanda said this. Okay. There's so many Rajeshes. I see different profile images. Okay, I think Rajesh is probably the most common name amongst the participants here. But it's interesting. The practical hack that he's suggesting here is, let's just do some simple outlier detection using something like IQR, right? Let's find these outliers. Let's find these outliers. These are all inliers. Train different models for them. Train one model for this guy. Train one linear regression model here. Train another linear regression model here. Train another linear regression model here. You're done, right? Remember, in the real world, if you have significant data like this, and if you don't want to discard it, probably this is useful data. For example, imagine this X is some heart rate. I'm just trying to come up with some heart rate, and Y is some other biomedical metric, right? Then what you could say here is, hey folks, those who have very heart rate behave very differently from people who have regular heart rate. Similarly, those who have very low heart rate, their behavior is very different. Fundamentally, it is different. Hence, it is better to say, train a different model on this, train a different model on this, train a different model on this. In the case of internet companies, right? Oftentimes, the traffic from web data, there is a different model for it. The traffic from Apple devices or iPhone has a different model for it. The traffic for Android has a very different fundamental pattern. That's primarily because on the web, the browser interface is very different. Like I've seen this at many companies. It's also publicly discussed in their technical blogs that companies like Facebook, Instagram, all of these people, right? I don't think Instagram has a mobile thing, but at YouTube for sure, right? So the web interface is different, and the metrics that you'll observe on web are very different from what you'll observe on a device like an Android, iPhone, etc., etc., etc. Again, more and more the iPhone data will be differing from other devices because more and more privacy and other things have been put in recent versions of iPhones. Okay, simple. That's it. Simple problem. Just train different models. It's a simple practical hack. It works. It works brilliantly well in the real world. Okay, cool. Yeah, so again, there are multiple strategies to find what are outliers. You can do clustering based methods, density based methods, like we discussed about local outlier factor, many strategies. You can use any strategy of your choice, find these outliers. You can even find outliers using methods like ransack, many strategies. Just make sure you understand fundamentally that this data, and this data are different. Train different models, you're done. Okay, this was an interesting question. Cool. So let's go to, okay, here is another question. Okay, very interesting question. So you're training a GBDT model, right? Somebody was talking about gradient boosting ensembles, right? So let's tackle a GBDT problem here. You have 10,000 points. Each of your data is 20-dimensional data, right? Small data, not too large. 10,000 points, 20-dimensional data. And you're training a model using 100 base learners. And the maximum depth of each of your base learners or the trees, because it's an ensemble tree model, is 3. It's not too large because you're doing a boosting approach, right? What you observe is, suppose you have written some GBDT code on your own and you start training it. It's taking too long. It's taking like 10 hours to train a simple model like this. This is not too large. And let's assume you have a decent laptop/desktop. 10,000 points, 20 dimensions each, 100 base learners. The maximum depth of each tree is 3. So you're literally building 100, you're simply building 100 depth 3 trees. Of course, you're doing some optimization in between, but it's taking too long. So how do you debug this and how do you fix this problem? Again, this is a medium difficulty because it's slightly open-ended. Okay, cool. Let's hear your thoughts. Okay, so anyway, think about it. This is an interesting problem. Actually, early in my career, this actually happened to me. Change the base estimator. Why will you change the base estimator? Okay, let me write all of your thoughts here. I'm sorry. So you can't change the base estimator, right? Because in a GBDT, the base estimator is a tree, right? The max depth is also sensible. It's not too small, not too large. 3 is not too bad. Should we investigate on initialization? Okay, there are some general questions. I'll come to that at the end, Prabhu. So Sai Shushant says, should we investigate on initialization? What initialization are we talking about? Because in GBDT, the first model is basically an average model that you have. Okay, let's assume this is a regression problem, just to make your life simpler, right? Let's assume this is a simple regression problem with squared loss, right? Because GBDT requires a loss function that is optimized, right? So your initialization is not a big deal here. So Shubham says, can we divide the whole data in small batch and train? Like, that's not needed here, right? Your data is not too large. 10,000 points will easily fit into RAM. Each point is only 20 dimensional. So this should not take 10 hours. There is some fundamental problem in what you have done, right? Why is it taking 10 hours? How do you debug this problem and fix it? Reduce base learners. 100 is not too large, folks. Like, if you have not messed it up, this should not take more than a few minutes. Like, I'm very sure I can train a model like this in under an hour on a mid-level laptop. Change parameters like reduce base learners and then try. I mean, 100 is not too large, by the way. So don't worry about reducing it further. Sample data from dataset. The data is not too large, 10,000 points, folks. If you have ever trained a GBDT model, you will not give these suggestions. Again, as an interviewer, the interviewer will easily understand that if you give suggestions like this, they'll know that you have never trained an actual GBDT model, right? Because if you have trained it, you will know how much time it takes, right? Use distributed processing. Why the heck should I use distributed processing? 10,000 points, 20 dimensions, 100 base learners, max depth 3. Please try it on any decent laptop or desktop. It will take no more than an hour. How do you, somebody is saying parallelize, for God's sake, how do you parallelize the construction of base learners in GBDT? Sorry, how do you parallelly construct 100 base learners? Please tell me. This is not a random forest. This is a GBDT. How do you do that? That's not possible because it's a sequential model. Can data normalization work? Let's assume data is already normalized. Good point. Let's assume we have normalized the data. Can we change the learning rate to come up with individual models? Let's assume even with a fairly reasonable learning rate, it's still taking too long. Somebody suggesting we'll try extreme trees. We'll come to extreme trees later. What is the problem in this GBDT? We'll come to the solution later. The problem with extreme trees is you will need many more base learners than 100 to get the same performance. Check the learning rate by limiting the feature. Hyperparameters are not the best. Again, I'm taking very, very conservative hyperparameters here. Let's assume this is the first hyperparameter values that I'm trying. 100 is not a big deal, right? 100 is a very sensible value, not too large. Let's assume even with 10, it's taking too much time. Okay, back to your question now. Learning rate is too small. Let's assume you're using the default learning rate or a sensible learning rate. Let's assume. Can we change the loss function for the pseudo residuals? Why would you want to change it? This should work, no? Folks, the question here is, with this sort of simple setup, it should work. Something is fundamentally wrong in what you have done. Imagine you're working in a team, your colleague comes and says, boss, this is not working. Can you help me debug it and fix it? This has happened to me in my own experience. It might have got stuck at a saddle point. Like even if you get stuck at a saddle point in the larger optimization problem, you can still train the 100 base learners, right? Are we using row sampling? No, you're not doing it. Are we using row sampling and column sampling? Oh, good question. So let's assume we have some sensible row and column sampling values. Not too small, not too large. Some sensible values. Because depending, again, if you're using a library like XGBoost, it lets you column sample and row sample. Let's assume we have some sensible values. Reduce dimension. Why should I reduce? There are only 20 dimensions, folks. This is not some 1000-dimensional problem. Features removing. Why? It's only 20-dimensional problem. Computation of pseudo residuals is taking a lot of time. That can't take time. It's just a linear time system. Like if somebody says that, I'll say, what is the time complexity of computing the pseudo residuals? It's linear in the number of data points. It's just order of 10k, which is n, which is the number of points here. It should not take this time. Think about it. There is a bug in error computation. No, let's assume there is no bug in error computation. Max features. There are only 20 features, no? Data might not be good. What do you mean data might not be good? Can you please elaborate, Sriram? Features might have high cardinality. Again, this is Rajesh Sharma. Very good point. Very happy to see you, Rajesh. Again, even in our internal discussions, I see you doing very good. Good. Yes. So one of the fundamental problems here with most GBDTs or any tree-based ensembles is, what if you have categorical features? This is a fundamental problem. What if you have categorical features with many categories? With many categories. This is a fundamental problem. I have seen this in the real world when I was working at Yahoo Labs. Okay, this problem occurs. And as a beginner, as a young machine learning engineer, it took me some time to debug this, but it was one of the great lessons of my life in terms of practical machine learning. And I've seen this problem reoccur many times later. I've seen interviewers at companies like Amazon ask this problem to test how you can think about it. The moment you have a decision tree, look at what takes, again, you can actually systematically think about it. Even if you have not experienced this, systematically think about this problem. You're basically constructing some decision trees of max depth 3, right? You're basically doing this. You're basically doing some 100 such base learners. In between, you have some pseudo residuals, etc., which are not very high time complexity. So what is taking so much time is constructing each of these base learners. But you have only max depth 3. If it's only max depth 3, why is it taking so much time? Probably because to actually split a node, it's taking too much time, because you have, let's assume of the 20 features, you have, let's say, some feature 10, which is a categorical feature, right? With, let's say, let's say 500 categories or something like that. Huge number of categories. Now, the moment you have large number of categories, most of the times we encode this using your standard one-hot encoding. Right? There are also libraries which by default encode all categorical features into one-hot encoding. Right? The moment you have one-hot encoding, the number of features have suddenly exploded from 20 to 500. So 19 plus 500, 519 features. Which means for every feature, now I have to say, should I split on this feature or not? That is what is eating up a lot of your time. Now, if one feature has this problem, imagine if I have some 5 or 6 features which are categorical with many categories. It will take a lot of time, right? Again, you can arrive at this solution from first principles. That's what I'm saying. The moment you have decision trees, remember, for any decision tree based model, if you have categorical features, this is, again, we've discussed this in our course videos also, that this is one of the biggest problems with any decision tree model, which is if you have categorical features with too many categories, it will not work as well, right? So there are 20 features, no? I said there are 20 dimensional each. Again, when I said 20 dimensional, I mean there are 20 features each. Now this problem can be exaggerated. Okay, so let's talk about the solution for this. Again, there is one more problem that I wanted to elaborate on. Okay, so the other problem here is, imagine if one of the features is text, is a text, like a string, okay, or a paragraph of text. Then typically what do? You either do it as bag of words or TF-IDF type of representation, which also shoots it into a very high dimensional space. You'll run into this problem not just for categorical features, for also text features also, right? So how do we solve this problem now? Again, first let's talk about how do we solve this problem for categorical features, then we'll see how to solve this problem for text features. Okay. Okay, so Rajesh is also saying there is one more area of problem which is interesting, which is if your feature I, let's say zoom, is real valued, right? If it's real valued, then you have to try for each of these 10,000 possible thresholds, right? Because you have a model like this. Let's assume all the 10,000 values are different, then you have to try for each of these 10,000 unique values, which is true. That also could be a problem. And I see a lot of students, and whenever I interview our own students, I do easily like at least 5 interviews a week for our students. A lot of them say, hey, I've used Cat Boost because it has performed well. The first question I ask them is, how is Cat Boost different from XGBoost, or how is Cat Boost different from your standard GBDT, right? Or GBDT that's there in sklearn. Lot of times, almost 90% of the time, students can't answer it because they've just used it as a black box. Okay, cool. Okay, so some of you are suggesting ideas. So if it's real valued, one suggestion is bin these values, right? Very good. So bin these values to speed up things. Very good, valid, perfect. You can just do some binning and go ahead with it. What about categorical features and text features? Okay, so somebody suggested using response coding, right? Very good. So response coding basically says what is the average or what is the median value, right, of yi, right, given this categorical value. Suppose if F10 has, let's say, 500 categories, let's say C1, C2, C3, so on and so forth. So what is the average value of yi, because it's a regression problem, given that feature 10 equals to category 1? You can take average, median, whatever works for you. This is what you do in response coding. Cool, this works. Now slightly tricky. What will you do if it's text? Very good. I'm happy that all of you are suggesting good solutions here. Very good. So somebody suggested use probability score. What is a probability score? I think I mentioned that we are solving a regression problem here, right? So there is no probability score here, just to be sure. Sentence encoding. Okay. So one suggestion, one way to fix this is you can use something like when you have text or string, you can pass it through a deep learning model like BERT and get a text vectorizer. But oftentimes, if you use the default BERT, like transfer learning based systems, you will get typically 512 dimensional numerical vectors, which is also quite large for this problem. Remember, this problem has 20 dimensions only, or 20 features, right? So this is a problem that you might run into. Okay, okay, somebody is suggesting we can do some hashing. Yes, so you can do, there are some hashing based solutions that you can employ. Good, good. That is one idea. What else can we do? Any other ideas? Yeah, so you can do only top K words, right? You can do top K words. Very good. All these are valid solutions. All these are valid solutions. There is one more solution that I wanted to just suggest you. Probability encoding technique for categorical features. We are doing response coding, right? Response coding anyway takes care of all the average values. So another very interesting hack that you can use here is you can say what is the average value of yi given this sort of sentence historically. Now you have to break down this sentence now, because sentence is a group of words. The same sentence may not always repeat. So you can use something like a naive Bayes type of split. Okay. So again, naive Bayes is for probabilistic scores. Here what we have here is real valued scores. So there is you can do something like a naive Bayes sort of setup, and you can say what is the value of yi that you can expect if you see this word, right? So one way to write that is you can say what is the value of yi if you encounter, let's say, word j, right? You'll get some value. Similarly, you can say what is the value of yi that you can get if you see wk. So all these values, so you'll get some value here, you'll get some value here, and so on and so forth. Now in naive Bayes, you just multiply them because of the conditional probability. Here in regression, you can't multiply them. So you can take some metric out of it. You can try various metrics. You can say, hey, what is the average value, or what is the median value? You can say, what is the average value of yi if I see this word wj in this sentence? Of course, you do your standard remove stop words, all of the standard stuff, standard text pre-processing. And you can say, what is the value of yi if you see word k? You get these values, you compute some metric on top of it, right? If this was a classification problem, you compute these probabilities and you simply say, just multiply them like naive Bayes, right? So that's another way you can encode text. Okay, so then this model basically is you're using naive Bayes like scheme to encode your text and give it as a feature, then the whole thing follows. Okay, that's another way. I'm not saying it is the best way, it is just another way. Again, you can't use TF-IDF because TF-IDF also generates very high dimensional feature space. Okay, cool. Yeah, you can use distill, BERT, all of them, but again, this also generates quite large dimensional vectors, which could be problematic in this setting. So just be careful about them. Okay, sounds good. So this was a good discussion. So let's go to, okay, it's already 8:42. Okay. So we have, I think, 2 more questions. Okay, let's tackle some of them anyway, since we are at it, right? So given 1,000 images of cars, okay, so let's assume you got some, I'll give you a real world example. Suppose you used some Bing search or Google search API to get 1,000 images of cars, right? You got all the cars, but when you visually see it, some of the images are actually not cars, okay? Because Google search might be using its own technique, its own stuff, right? So let me just show you. This actually happens in a lot of data. So imagine if you have this problem that you collected some 1,000 images using search keywords like cars, etc. But you know that approximately 100 of these are non-car anomalous images. Now, you want to filter out these anomalies. You want to filter out these non-car anomalous images without using transfer learning. This is like an easy to medium problem in deep learning. How will we tackle this? Again, if you know the concepts, this is straightforward. Okay, any thoughts on this? Take your time, think about it. Let me put the problem here. So you're given 1,000 images of cars which you obtained by scraping somewhere on the web. And by just quickly scanning, you see a lot of anomalous images which are non-car. So somebody says that we will cluster similar images. How do you cluster images now? These are all color images, right? They are very high dimensional data. So let's assume each image is 640 cross 480 cross 3. I'm just taking an example. If you just go ahead and convert this into a big vector, you get huge dimensional vector, right? So clustering is non-trivial. Again, clustering on the raw pixels is never beneficial. What are these anomalies? Good question. So these anomalies are basically non-car images. Maybe you got some trucks. Maybe you got some toy cars. Okay, not actual cars. Maybe you got some maybe horse carriage images by mistake, because search is never perfect, right? Suppose you have some of these. How do you get rid of them? Somebody is suggesting PCA. So how will you do PCA? Can you please elaborate on that? Because remember, the data that you have is fairly high dimensional in terms of the feature vector itself. Can you please repeat the question? Sure. So given 1,000 images of cars that you scraped from the web, you scrape the web using some search engine or other sources, like whatever image sources that you have. When you quickly scanned it, you saw that there are some non-car images also. Let's call them anomalous images. How do you now, given these 1,000 images, filter out these non-car anomalous images without using transfer learning? So somebody is, okay, so let me write your thoughts here. Okay, so I'll go step by step. So somebody is saying that we will pass it through filters to extract edges. Now, if you're trying to use any standard CNN like architecture, the problem here is CNN architectures have some loss at the end, right? Typically like a classification loss, right? Or a regression loss. Here we are just given data. We don't have any yi's. All you have are xi's. There are no yi's here. So how do you even train a CNN model from scratch? Number one. So number two. So let me go to other suggestions. So somebody is suggesting that you will transfer into a classification problem that cars is class 1 and non-cars is class 0. But you don't know which are cars, which are not cars. Imagine instead of 1000 images, you have 10,000 images. It will take a lot of time for you to manually label, right? You can't manually label. Let's assume you don't have the bandwidth to manually label all of the data. Okay, so this won't work. This won't work. Third option. Let's go. So somebody is suggesting PCA. How do you use PCA here? Can you please elaborate? Number one. So others are suggesting, somebody is suggesting DB scan. How do you use DB scan clustering here? Will you just cluster on the raw data, which is 640 cross 480 cross 3? If you're doing any clustering on the raw data itself, it may not work very well in the real world. So others have suggested using SIFT features. Again, SIFT features are useful, but they may not be the best in this case. This could be made to work with SIFT plus some clustering, right? Again, SIFT features themselves were primarily designed for a search task, not for a clustering task. So you will need, again, SIFT is basically a type of classical image processing computer vision features on image data. You can get this to work, but it's going to be non-trivial. Is there any better solution than that? You can't modify it as a classification task. Use distance-based approach. How do you compute the distances? Distance-based approach like k nearest neighbor, etc. Or some density-based approach. How will you get the feature vector? Will you just take this 640 cross 480 into 3 and flatten this whole tensor to get a feature, to get a vector? Then it may not work well. Okay, good. Okay, after some thought, I'm getting good answers here. So standard approach is autoencoders. This is the standard approach. Okay, so autoencoders is literally like the golden trick here, right? This is one of the purposes of autoencoders is to find outliers, right? Is to find outliers, is to find anomalies. Again, we describe a lot of internal details of autoencoders in our course videos. I think we also have a CNN based autoencoder code walkthrough in our course, right? So this will work. So for those of you who don't know what is an autoencoder, this is how it roughly works. Again, I'm not going too deep into the mathematical details. You give it an input image, right? It goes through some convolution layers. Okay, so let me just write it as some convolution layers. Now the question here is, how do you train these convolution layers? So it might go through a bunch of convolutions. Then there will be some flatten. So this flatten is like you'll get a vector. Then you'll have deconvolution operators, right? So you'll have deconvolution operators. And after deconvolution operators, you'll generate the image again. So let's assume this is image output. This is image input. Now your loss function basically is sort of loss between input image and output image. It is how different is the input image to output image. That's how we can compute your loss function. A simple loss function is pixel-wise difference. Now, when you pass these 1000 images that you have, all of them being cars, again, the loss is basically some difference between input image and output image. Okay. Again, you can use very simple difference like a pixel-wise difference. That's the simplest. Again, autoencoders are also used for denoising images. Those are called denoising autoencoders. But one of the simplest applications of autoencoders here is, given your images, again, remember through convolution, you're trying to get a feature vector corresponding to this image such that from this feature vector, you can apply deconvolution operators and generate the whole image as closely as possible to the input image. That's the beauty of it. Again, you're using all of the standard machinery of a standard convolutional neural network. Again, this is the autoencoder architecture. Now the beauty of this is when you pass all the 1000 images, again the game is not yet over. What happens is, because most of your images, let's say 900, approximately 900 images are cars, 100 images are non-cars. Because a vast majority of your data is car-based images, the whole weights in your convolutional neural network and the deconvolution layers will and again the whole featureization to this vector will be such that the most important part here is it will encode the details about cars better. It will encode everything, all the information about cars better than non-cars, because non-cars are a minority. So what happens here is, after you train this whole network through backpropagation, standard stuff, right? Finally, what happens is you have an architecture. Now, if you look at the loss, or you look at the difference between input image and output image for all of the 1000 images that you have in your training data. What happens here is, for the car images, this difference will be small. For the non-car images, the difference will be larger. Okay, this will be smaller. Right? So then what you can do here is, you can sort all of these 1000 images. Again, you can build a very simple UI for this. Sort all the images such that those images with larger error or larger difference between input and output image are at the top, and most of these will be non-car images. Okay. Again, you might have to do a little bit of manual intervention here, but most likely it will be pretty good scheme. Okay. Very simple. Very easy. Again, this is one of the biggest purposes of autoencoders. Okay, so very simple solution here. Cool, very nice. Okay, so there is one more question. Okay, we're already at 9 p.m. I'll give you this question and I will leave it to you. Okay, so think about this question, and you can share your ideas in the description box below for this live session, right? So how would you design and build a grammar correction system? Many of you might have heard about this plugin called Grammarly, right? Which is like a Chrome or even operating system plugin, right? Which you can, I think there is also a plugin for Google Docs, where if you write any sentence that is not grammatically correct, it will immediately detect that. Again, such a system also is there in Microsoft Word. I think also in Google Docs, if I'm not wrong. So how do you design and build such a system from scratch? We would rate this problem as slightly harder, because here you're building an end-to-end system. So the challenges here is, how do you acquire data? Where do you acquire data from? Imagine you're a data scientist where you don't have a lot of this data. Suppose you join a company, or you start your own startup, or you join a team which says, hey, let's build a Grammarly competitor. Okay. So how do you obtain the data? What sort of models will you experiment with? Again, remember, there is a latency requirement here. These models should run very, very fast, even on your laptop, because you typically type it on your laptop and you want the grammar correction system to work partly on your laptop. It could also partly run on your servers, right? So how do you design this end-to-end system? This is a very good question. And this is especially, again, as some of you are already pointing out in the in the chat window. Yes, the state of the art for grammar correction systems are BERT or GPT based models. That is true. But this is just one piece of the larger puzzle. But again, when interviewers are looking for the slightly harder questions, they're looking for everything from data acquisition, data cleaning, what are the submodels, what are the modules of the system. It's like an end-to-end design question. Models being one of the components of the larger ecosystem. The moment you say BERT or GPT, the follow-up question here is, it can't be run with low latency. How do you now tackle that problem, right? So it's a non-trivial problem, right? Even if you're trying GPT-based models, the same problem. How do you run a low latency model on a low-end computer? Okay, think about these. I would like to hear your thoughts in the chat window. Okay, so as I promised you, we are already 2 hours in the discussion. These were the 6 questions that I had. I thought I would complete them in 1.5 hours, but we could not even complete them in 2 hours. But I'll take some of your general questions for a few minutes, and then we'll wrap it up. Okay. Again, I'm sorry for stretching it a little longer, but think about this question and please write your comments in the chat window. In the comment section under the video, because the comment section will be visible even afterwards. Okay, so somebody is saying for this question, can we use try and edit distance? Again, tries and edit distances are typically used for correcting spellings, not grammatic corrections. Yes, for spell check, the standard solutions are typically your try-based models. Okay, cool. Which math books do you recommend for maths for machine learning and deep learning? Okay, so let me just open up my browser there. So for deep learning, this book is good. Ian Goodfellow's book is pretty good book. I really like it. I think, okay, so there is a public version, right? So there is some mathematics that is covered here. If you see this, linear algebra, probability, it's not fully exhaustive, but it's a pretty good coverage of the basics. Again, there is no limit to how deep you can go, right? Because you can learn, like I'm still learning a lot of advanced statistics and advanced mathematics, right? So there is no limit to how much you can learn. But if you see this deep learning Ian Goodfellow's book, it is slightly old, but it's still a very good book because the foundations don't change every year. The state of the art changes. Like there is also autoencoders here, right? So the same, this book is very, very well written. So this book was one of the first books of deep learning that I read outside of research papers, and it was terrific. Like I still have a copy. I bought it online, a physical copy, and I still love reading through it sometimes. Some of these concepts are outdated enough, but still a good textbook. Good books for NLP. Unfortunately, NLP is moving so fast that there is no one good book for it, to be honest with you. I would say instead of reading books, the state of the art NLP is all deep learning based with Hugging Face. So my suggestion for you here would be, okay, resources. Go to Hugging Face. They have some blogs and they also have, do they have some tutorials, organizations, documentation? Okay. Inference, transformers. Okay, so if you want the code aspects of NLP, go through the Hugging Face library. That's a great place. Again, this area is changing so fast, especially with transformer based models, that I don't think there is any modern textbook that covers it in depth, to the best of my knowledge. For classical NLP, there are books, but I mean, every day we are moving to more and more advanced stuff like more and more advanced transformer based models. So there are some O'Reilly books, but I've not read them, so I can't recommend them. So most of NLP I read personally, most of our mentors also, from standard research papers. Research papers are very good. Like if you can't understand a research paper, like you can say, suppose if you want to understand BERT, right? Again, we explained in a lot of detail in the course videos with code and everything, but if you're not a course enrolled student, so just type BERT blog. Okay. Here is a very nice blog by Jay Alimer. Very nicely written intuition of BERT, right? Very nice. I mean, this is, again, unfortunately doesn't go too deep into the mathematics and too deep into the architecture, but it gives you like 80% of the idea you can get about BERT from these sorts of blogs, right? So very nice blogs. So use these blogs to understand the concept, use Hugging Face for code parts. Okay, that's what I would recommend here. Cool. Okay. ThinkStats is good for statistics. Again, Prabhu is asking a very interesting question here. ThinkStats is a good book. There is also a freely available version. ThinkStats, Green Pea. Okay, so ThinkStats is a very practical book. What I like about it is this is very programmer friendly. It is very hands-on programming, applied probability and stats. There is less theory here, but it covers all of the applied aspects very, very well. There are some concepts that are not covered in depth, like resampling, permutation testing, etc. But this book is freely available, a great place to learn if you're interested. I think for ThinkStat, some of the code is also available in Python nowadays. Okay, I think I answered the good books for machine learning. Okay, so you're talking about data science and machine learning. For machine learning, okay, there are many books, but I mean, if you have time, pattern recognition book. Where is this book? This is one book that I liked. This is Christopher Bishop's Pattern Recognition. It's more theoretical, but it's a good book. You can read it. If you want, like the Elements of Statistical Learning is my favorite book because it's written very rigorous math, but it's a harder book to read. I think there is a publicly available version also of this book. You can download the PDF version. But the elements of statistical learning is math heavy, and please don't read it as your first book unless you're very comfortable with math. Okay, so pattern recognition also covers math well. Again, this is a standard textbook at most universities, but unfortunately these books don't have too much hands-on stuff, right? For that, just go through any good O'Reilly books. They give you more hands-on stuff. They lack the mathematical rigor. Okay, so Kaushik has, even after completing the course, is it okay to go for PG in AI ML? Again, we have a lot of students who go for PG programs abroad, PG programs in India. We have a lot of postgraduate students. We have PG diplomas. There are a lot of our PG diploma students who are also our AI course students who wanted to get academic credentials. So that works. I mean, that's perfectly all right. What about the progress of PG in AI machine learning? How are the students doing? A good question, Abdul. I'm very happy about them. I think there was a midterm exam today. Actually, to be honest with you, I was very surprised. I mean, a lot of our teammates were also surprised on the amount of effort that many of the students are putting in the diploma. We really love that, love the amount of effort they're putting in. Many of them are also scoring well in the midterm exams. We had one midterm exam already for the programming course, which is basically called Foundations of AI Machine Learning and Python Programming. The second course is basically data analysis, visualization, probability statistics. We just had a midterm exam, so we will note the results in 24 hours. But we are very happy with the way they're performing right now. Again, we'll have to see the whole program. We still have many more months ahead of us. The first semester will end by end of July. Early August, but till now, whatever we have seen, their participation in sample tests, their participation with assignments, we were very happy. We didn't expect such a good participation. So even live sessions, as compared to applied AI course students, the diploma program, a significantly larger percentage of students attend the live sessions. So again, that's the advantage with some academic programs. So Prabhu is saying, I'm reading Hands-on Machine Learning with Scikit-learn. That's a good book. You can read it. That's a good book. Srikanth has a very nice question. Do we need to explain about our company projects in and out when you interview? If yes, does that violate company confidentiality? Very good question, Srikanth. So a lot of interviewers also understand that you can't tell all the details. They understand that, to be honest. So whatever you're not comfortable saying, especially the numerical values or company trade secrets or patents that you or your teammates have applied, just say, I cannot disclose more than this. Interviewers understand it. I've been an interviewer, hundreds of interviews. I've been an interviewee also. So it's perfectly valid. People understand that, right? So another question by another Srikanth, share my same first name as me. How far is the course going to help me in my research? Again, Srikanth, to be honest with you, this whole applied AI course is not designed keeping research in mind, but we have a lot of masters and PhD students across the world who take the course primarily to make their applied understanding and foundational mathematics stronger. This course will not help you publish research work, but it will help you have very strong applied foundations of the concepts. Okay. So, I mean, it will not help you publish research papers because it takes a very different mindset and workflow to publish research papers, which we are not geared for right now. So is there a PG diploma batch starting on or before July? Prasad, I cannot comment on it now, but most likely yes. Okay, I cannot give you an exact date, but in the second half of this year, we will have we'll most likely have, I cannot say we will surely have, because we need to get a written confirmation from University of Hyderabad, but most likely we'll have the second batch in the second half of this year. Okay, so there was a nice question from Chavan, which is 15 plus years of experience. Can I switch to data science? 8 years of IT experience. Very nice question, Chavan. So for learners like you, what we recommend is, given that you're already in the IT field and you have a lot of experience, my suggestion for you is as follows. please take whatever you're learning in the course and apply it to the current projects that you're working on. That is extremely important as you gain experience, right? And try to build on top of your existing experience, given that you have this enormous amount of experience. So we have had students like you who have built on top of their existing, like we have had architects, we have had managers, we have even had senior managers with like 10, 15 years experience also, who have learned machine learning data science, applied it to the projects that they're currently working on, and slowly moved into a machine learning architect or a data science architect roles. Some of them also as managers and senior managers for data science and machine learning teams. So that is very possible, but you have to make sure that you're applying whatever you're learning in the course to problems you're solving in your current team. Again, please reach out to us over phone so that one of our mentors or co-founders can answer your questions in more detail. So Ankit says, can a transition from AI ML role to business analyst role? That's a very natural transition. From business analyst, I'm assuming that you've done some basic data analysis and you understand the business context well. We have had people with business analysis or business analyst type of backgrounds who have moved into data analyst or data scientist or even AI machine learning core roles. So that's a natural transition that you can go into. So Abdul says, is it enough to complete the PG program with University of Hyderabad and land a job with 6 to 7 lakhs LPA? Abdul, the course itself, the whole program in collaboration with UOH has been designed to crack even the top product-based companies. We are very positive that students who perform well, who learn well, who do all the assignments, who score good marks can crack good top product-based companies with compensations north of 15 lakhs. So 6 to 7 lakhs should be easy, but remember that your learning is what matters. And thankfully in an academic setup, what we have is we have regular midterm exams, weekly assignments, the standard format that you would expect in an academic program. So if you go through the program rigorously, religiously, do well in it, 6 to 7 lakhs should be straightforward. So Rishabh, okay, so there is a U there, I got confused. Okay, Rishabh. So does knowing programming like in competitive programming help in machine learning programming? Very good question. So if you are good at competitive programming, that is extremely helpful because at the end of the day, you can attempt for machine learning engineer roles, which are basically software engineers who do a lot of machine learning work. Those roles, there are very few people who can fill those roles because most data science folks are not at the same level of programming as a good software engineer would be. So if you have solid competitive programming skills, you can easily transition into machine learning engineer roles or applied scientist roles comfortably in good companies. So knowing that always helps. So having strong programming skills will help you in the long run without doubt. So okay, so can final year BTech students take this course? So Pratish, if you're asking about PG diploma, we will announce it officially as soon as we have a written confirmation from University of Hyderabad. As far as applied AI course itself is concerned, certainly you can take, certainly you can participate in applied AI course. We have a lot of undergraduate students who participate in it, right? Cool, sounds good. So yeah, so I know that I've overshot significantly, but I hope these questions gave you a good flavor of what to expect in terms of scenario-based questions for data science, machine learning, and deep learning. Again, I would love to see your thoughts, your ideas on how you would tackle the design and building a grammar correction system like Grammarly end-to-end from data collection to deployment. Okay, so see you in the coming weeks. Thank you very much for participating and have a good night. Most importantly, please stay safe. Just because the COVID wave is down doesn't mean that everything is done. So let's stay safe. Let's get vaccinated if you can. Thankfully, some of us got vaccinated. If you can get vaccinated, please do get vaccinated. Most importantly, stay safe. Let us be part of not having the third wave. Okay, let's do our job in that. Okay, thank you very much, folks. Bye-bye.